In this topic, we will understand what can go wrong when we combine both encryption and compression. This can result in breaking SSL with compression. So this is an elegant idea which TLS 1.3 encryption failed to defend against. In TLS 1.3, each frame is divided into 16 KB block and then encrypted before sending. So essentially, we wanted to compress data as we don't want to transmit huge data over the network. So the question is, how do we combine both compression and encryption? So the compression ratio info leak made easy, acronym as CRIME, is a security exploit against secret web cookies over connections using HTTPS. So it allows an attacker to perform session hijacking on an authenticated web session. In this approach, attacker observes the size of the ciphertext and change in the size of the compressed request payload. So when the size of the compressed content is reduced, it can be inferred that it is probable that some part of the injected content matches some part of the source, which includes the secret content that attacker desires to discover. So the browser is sending data to the bank and the browser is sending instructions to buy some item. So everything over the network is encrypted and the attacker observing the traffic doesn't know what is sending. So this is a very clever attack and a beautiful idea. Let's see how this is done. When user is authenticated to the bank, cookie is set in the user's browser. So basically, users are authenticated to the bank using cookies. So the attacker goal is to steal the user bank cookie. So once the attacker has the user's cookie, he can replay the cookie on behalf of the client. So the first thing that attacker does is he will lure the client to some website and he will inject some JavaScript in his browser when he visits that website. So this JavaScript runs inside the client browser. Now the attacker is sitting in the client's browser via JavaScript and he can do whatever he wants. So this JavaScript can issue requests to the bank on behalf of the client, and this JavaScript cannot read the cookie. So all the JavaScript can do is send request to the bank and cause the cookie to embed in that request. So the first thing that JavaScript will do is it will issue request to the bank by creating a very long URL which pushes everything out of the 16 KB frame except the first byte of the cookie. So the URL is chosen to be so long that pushes everything out. Now this whole thing gets encrypted and compressed and sent to the bank. Now attacker observes the size of the ciphertext and change in the size of the compressed request payload. So in this example, we have UID is equal to A, which is the cookie data, and followed by all ones. And this is a very long URL which pushes everything out from the 16 KB frame except the first byte of the cookie. So the attacker tries with B. Now when UID is equal to A, compress with the same size as with UID is equal to B. Now he tries with C, he tries with D, he tries with E, and he reaches to the point where he encounters J. When he reaches J, attacker gets a better compression ratio than the earlier request. Now what happens is when the UID is equal to J is matched on both sides, and as a result we get a slightly better compression. So the request that got is compressed and encrypted is shorter than the earlier request. Now the attacker can guess the first letter of the cookie is J. Now attacker will change the second letter and will send requests like JA, JB, JC, and will reach to a point where it is JH. Now the attacker get a better compression again than the previous request. Now this attack is performed with 256 into length of the cookie items and can guess the cookie information based on the compression ratio. So this way the attacker can guess all the cookie data. So the UID is equal to JHPLAG can be easily exploited based on the attack that he wants to perform with the 256 into length of the cookie items. And this is a serious problem. What can be done? One approach is to disable the compression. So we need to re-engineer most of the applications not to combine both encryption and compression. Also, we need to update cookie for every request and response that is coming from the bank.